Hello, this is my final science video, and wow, it's just been a crazy semester. Um, yeah, thank you so much for everything, and yeah, without a doubt, here we go. And so, for the first question, it talks about misconceptions of students for science. So, what a misconception basically is that students and even us and everyone in the world, they just have a misunderstanding about certain things. So an example of that could be like in science that the North Star is the brightest star in the sky, which is false. It's it's actually the sun, obviously, but not in the night sky. Sirius is actually um, brighter. And another example of a very common misconception um, is that lightning never strikes twice in the same place, which is pretty false and actually dangerous. Like tall buildings such as like the New York State, the Empire State Building gets struck a lot of times during the year. Or different tall buildings get struck a lot, and so those are just examples of what a misconception is, and how I'm gonna leverage these misconceptions. I think misconceptions, in a way, are actually a really good tool for a teacher because you can go in. Students, a lot of students, or at least some students, um, have this idea that they know everything and they already know everything. Everything else is boring because they already know everything, and they're pretty smart, which they are. But none of us know everything. So if you can go into a class and say, "Oh well, have you ever heard of, um, you know, like what do you guys think about this?" And the students like, "Well, this is my um, idea of what this means." And if a teacher is able to go, "Oh, well, actually, that's wrong," and let's try and figure out what the right thing is, or that's a misconception. Let's try and fix that. And I think a student's interest will be, that allows you to pique your student's interest because they're like, "Oh, wait a minute, like, there's something different to this. Like, I want to figure it out. Like, I want to investigate that." And so I think I'll give my students opportunities to investigate those misconceptions, right? Because it's not their fault. Like, it's just kind of how society works, and sometimes information just gets misconceived or misunderstood, or told the wrong way. And so as scientists, like, we're supposed to figure it out ourselves. And so I think giving students um, the opportunity to do that is something very important to me. Another thing um, about misconceptions is just um, that it's important not to get mad at the student, because how could you think that's wrong? I think, yeah, like I said before, as a teacher, it's important to use those as leverage. And yeah, we all have those misconceptions, so we shouldn't punish our students for those. And then the progressions of the standard. Um, so the NGSS has these disciplinary core ideas, and they actually build on top of each other, um, which makes sense because if you learn something in, say, kindergarten, like for example, um, my unit lesson was on energy, and so um, all through your life you learn about energy. Oh, that light turns it on. Oh, that's a form of energy. But in like even in like first grade and younger, like they learn about energy and how stuff works and stuff like that. So that's building on top of that, and they just keep building and building throughout the grade. So you're not just teaching something all the way at once, because students might not be able to handle that. Obviously, like if you tell like a kindergartner how the speed of light works, that might not, obviously that's not going to go well. Or if you try and help them, figure out how to determine velocity, obviously that's not going to work out well. But if you layer it on, that's going to allow that student to grow their knowledge as they grow. Um, and so that's kind of how that works. And then, so for a fifth grade teacher, um, their performance, their the standard that we were given was 4PS13, which talks about making observations and measurements. And so, to identify like materials based on their properties. So if you have this object, this big like block, you want to figure out what it is. Well, so like, um, say I have a box, I don't know if it's made out of wood or metal or plastic. Well, I can measure it or I can weigh it, and if it's really heavy, then I'll know, oh, that might be a heavier object, or if not, then a student can evaluate, oh, this is super light, that's probably plastic. And they'll also know like the qualities of those different materials, so they'll be able to observe it that way. And for instance, one way this is building off something they've already learned is that um, in fourth grade, which was what my lesson was over, um, one of the um, disciplinary core ideas um, was talking about making observations when it comes to energy, and that's what some of my lesson was built off of. So they've already made observations, like in all grades, they're making observations, and students are um, already pretty observing people, and they don't miss too much. So this is just building off of it, and to go into later um, in high school, they're gonna have to, make hypothesis and test those, and that's all about observations. And so they've already built off of it, and then they'll do this one in fifth grade, and then next they will do stuff later on in middle school and high school. So as you can see, it just keeps building all the way through um, this, all the way through the students' just learning career, but also, yeah, it's just building on itself. And then to move on um, to the to the 5E lesson plan. So the desired outcome for each stage. So the first stage is engage, and this is basically like your hook. You want to pique their interest. Kind of what I said, misconception, like, oh, have you ever wondered why um, this happens, or have you ever wondered why um, have you ever wondered why um, you know um, companies use big wrecking balls to knock stuff down, why they have to get them moving fast? Or you could have them even watch a video about say there's something sinking. Well, why did that sink? The students are going to think, why did that sink? How could we make that not sink? And then you could go into talking about buoyancy. Then you could have them doing an explore activity, which the explore activity is you're investigating a problem. And the big thing about explore is that you want to give students a chance for failure, pretty much. So you don't want them to be just leaning on you. So this is, like we did in class. You're not giving students all of the answers, and you're letting the students investigate on their own. So one I talked about is, they have to, test out different things of sound and observe, oh, what makes this sound and what makes that sound. And so they themselves are exploring what sound is. And for the explain is taking what they learned and talking about it, having a class discussion. Say you were having them, build build something, or like we did build a robot. Oh, well, what did you do wrong, and what did you do wrong? Oh, this worked for you. Oh, why did that work? Or what got easier? Or oh, for sound, let's talk about what sound is, or why did this heat up? Well, let's talk about like reflecting and absorbing heat. And so that's where you can really explain stuff and build on their prior knowledge. And then the elaborate is doing that. It's a second activity to build off the explore and the explain. Um, and so you want to do something more elaborative. So say they just learned um, about how heat works. Well, you can give them a task to build something that uses their knowledge. Like, oh, well, how does heat work? Can you make something to absorb heat to heat something up? We just talked about absorbing. So, what materials should you use? And then for the engineering process, basically they're solving engineering problems. So, they're basically becoming their own um, engineers pretty much. And so, um, yeah, so just there's different steps to that. And so there's 5 different steps. And the first step is they ask. So, in order to solve a problem, they need to, ask and figure out what the problem is. Then they need to imagine a solution. Then they need to plan or draw something out. So they need to have a plan in order to act on it. What materials, what are you going to do, how are you going to do it? And then they're going to improve that. And so they're good. First, you need to figure out what worked. Okay, let's keep what worked. Then what maybe didn't work. Well, let's change that. And so you're keeping what works and building on it and improving it, while also layering on things that didn't work before but now they work. So it's just a huge layering process for that. And then you just keep repeating. So you improve what worked, what didn't work. Then you imagine that, and then you test it, and then you just keep going and going. And this involves a lot of deep thinking and critical thinking and problem solving, and so it's really good for your students to do that within science. And a good way to do that is just in the 5E lesson plan. Talked about failure, talked about building, and so both of those I feel like go pretty hand in hand. And then for my feedback, yeah, it's been such a crazy semester and just crazy. No one could ever plan this. I really appreciate how, yeah, just willing, everyone was, especially Dustin or Mr. Merritt. I really appreciate, yeah, just everything you've done for me. And it's been a crazy semester for me. And yeah, I feel like I've learned a lot, and I love science and I love teaching. And yeah, I never felt gave up on. I never felt like, oh, just because I got bad grades or had some missing work, I'm a less valued student. And James, you've really done that a lot too, and I really appreciate. And so so have all of you. I think it's crazy. Um, yeah, how awesome it is to have 3 amazing professors. Um, and yeah, I really appreciate everything, and just being able to talk to everyone about teaching and about learning. And Mr. Merritt, I got to talk to you about just what it looked like to be a para and help students in that way and work within the system. And so yeah, I really appreciate just those conversations. Took a lot from it, and just your willingness to have fun and but be real and have that relationship with me as a student. Um, and I felt all the assignments were super impactful. I feel like doing everything, and running through those examples of what it looks like to have an explore activity. Maybe it would have been cool to give it more like ideas. I think sometimes I struggled with, okay, here's this, how do I turn it into an explore? And so that's something you might just come with time. I don't even know if you can work on that. So, yeah, this is Griffin, and I'm signing off. I appreciate everything so much, and I hope you enjoyed my video. And it was a pleasure being in your class, and I hope you enjoyed having me.